Okay, Bismillahirrahmanirrahim. We resume this paper from the fifth question. This is June 2020 and paper 3-2. So please, you must give it a try first and then I follow you people. So you must have tried this. So I need to tell you guys that see, when you have to write this in form of this cos over here, so for this expression the first term should be in terms of cos, and that is the case here. And when you have to write this in terms of cos here again, if this is x plus alpha here, there should be a minus between these two terms. So that is really matching here. So if you see these things matching, then you simply have your a, which is under root 2, and you have b, which is going to be under root 5. Please don't write that minus over here, okay? So the formulas are, your r is going to be the square root of a square plus b square. And we do have a plus minus with the square root, but since we're given that this r is positive, so we don't need to put that plus minus there. So he's also asking for the exact value of r, okay? So this r is now going to be the square root of 2 plus 5. So that will be under root 7, okay? Uske baad, we have to give alpha, which is between 0 and 90, okay? So the formula for this alpha is tan inverse of b over a. That is tan inverse of b over a. So guys, this alpha is going to be tan inverse of this under root 5 over under root 2. And you know that this under root 5 over under root 2 can also be written as under root 5 over 2. And just to minimize the number of keys that you will have to press on your calculator, you can assume that this is square root of 2.5. So can you please tell me, oh, I have the calculator here. So the tan inverse, we have to be in degrees mode here. This is shift tan of the square root of 2.5. Okay, so that is 57 point. Now it says we have to give alpha correct to 3 decimal places. So please you have to follow these instructions here. Okay, this is going to be 57.688. Okay, so finally we have this under root 7 cos x plus 57.688. So this is the one for which you can get 3 marks. Okay. Now let's move on to the second part. In the second part, we have to solve this equation here. Let me erase these things from it. Okay, we have to erase Kairam. But to solve this equation here, and if I take you back to the original equation, you must see that instead of cos 2 theta, we have cos x here. We have cos x in here, है ना? Yes. This is under root 2 cos x and under root 5 sin x. So going back to this here, I'll not be doing all that working to convert that into a form where we can solve this equation. So this first part is a hint. In fact, is a must for us to use because it says hence solve this equation. Okay, so let me write this equation as, let me erase them first of all. Okay, so I will be writing this equation as under root 7 cos, and instead of this x over here, I'll be writing 2 theta plus 57.688, and that is equal to 1. Okay, so I can erase this part now. Can you see that? The problem with the equation was that there was sine and the cos simultaneously present in the same equation. So you must have either the sine or the cos or maybe the tan in your equation. So we use this form so that we are able to solve such equations. Okay. So if you go back to your P1 trigonometry, guys, you see that is this. Okay, so this is going to be, we need to change this angle into a simple angle so that we can solve this equation. Okay, So let me say that this 2 theta plus 57.688, that is equal to y. Now my equation becomes really a simple one. This is under root cos y, that is equal to 1. And I should tell the limits for this y over here, okay? So using these limits of theta, I put the lower limit of theta into it and I get the lower limit of y, that is 57.688. Then I put the upper limit of y, that is going to be 180. This is going to be 360 plus 57.688. So that is 417.688. 417.688. Okay, so cos is positive because your cos y is 1 over under root 7. We are going to be in these two quadrants, okay? So let's see what is cos inverse of 1 over under root 7. So shift cos of 1 divided by under root 7. Okay, that is 67 point, let me write this 67.792. This is 67.792 because this is not the final answer, okay? Acha bachcho, now can I have my first value of y as 67.792? Hmm? You have to see that is
Yes,
this
sir.
within this range? Yes. Okay, good. So that is going to be so the first value of this y is 67.792, and then this was the first value, and then I go all along this here. So this is going to be 360 minus this. It's 292.208. 292.208. Let me check if I can have another value. So into this angle, I'll be adding 360. So if I add 360 into the 67 point something, there is going to be something 427. So this is going to go out of these limits of this y. So these are the only two values of y, okay? And do not forget that you were supposed to give the value of theta over here, okay? So this is going to be, your theta is going to be y minus 57.688 divided by 2. So you put them one by one over here and then you get the corresponding values of theta. So these are the two values of theta, yeah, that you people will be getting. Uh, can I proceed now if there is any no question? If there is no any question, no problem, no disturbance. Hmm? Okay, complete peace of mind. Okay, let's go to the next question then. Okay, here is the sixth question. That is, again, you see there's so much of calculus in this paper. We have just seen a question where there was a u dot v going on, and now there is a u by v to be handled here. Okay, so it says find the x coordinate of m. So you will simply differentiate this. Your u is x and your v is 1 plus 3x is per 4. Your u dash would be 1, your v dash would be 12x cubed. Okay, so the formula is the derivative of u by v is going to be v square and then vu dash minus uv dash. Okay, so this dy by dx is going to be, we have the square of v here, 1 plus 3x is per 4 whole square. Then you have v times u dash, which is 1, and then minus u times this 12x cubed. And I'll simply put that equal to 0 without wasting any time because we have to find that stationary point over here. So this denominator would be eliminated through that cross multiplication. I have 1 plus 3x is per 4 minus 12x is per 4 equal to 0. Okay, so this is minus 9x is per 4, that is equal to minus 1. So you have x raised to power 4, that is equal to 1 over 9. So this is going to be the fourth root of this 1 over 9. And you see, whenever you take the even root, it has to be plus minus. But this quite clearly, this is towards the positive side here. So I'll not be writing the plus minus here. So this is going to be 1 over under root 3. And first of all, the square root of 1 over 9 is 1 over 3, and then further another square root. And we have to give the answer correct to 3 decimal places. So this is 1 divided by the square root of 3. That is 0.577. Okay, remember, we only have to find the x coordinate. It says find the x coordinate. So don't waste your time in finding the y coordinate or finding the second derivative. Achha, let's see what is there in the second B part. It says, using the substitution. Okay, let me write this substitution here. U equal to under root 3x squared. We have to find the exact area of the shaded region. The exact area of the shaded region. So I'm going to go back to that diagram here, okay? So it says bounded by the curve x-axis and the line x equal 1. So that is basically quite clearly mentioned, shown here in this slide. So I'll be using this space here for this, okay? So let me cover all this given statement here. Okay, now I have space, the working now. So we have to use this substitution to find all this area. So this area is basically going to be limit from 0 to 1, and that is x over 1 plus 3x raised to power 4 dx. Okay. So we have to use this substitution. So, sometimes finding this du by dx before thinking about what to go about this x, that can really save us from a lot of working. So let me find du by dx from here. And that is going to be 2 under root 3x. This is 2 under root 3x. And you see that if I move this 2 under root 3 here, and I move the x to the other, this dx to the other side, that is going to be x dx. So this will help me to change this. Okay, so I will have here simply, I'm writing this 1 over 2 under root 3 out here, and I'm writing du here for x dx. Okay? Then there is 1 plus 3x is per 4. So if you are clever enough to see that if you square both the sides of this given substitution, you will have u square equal to 3x raised to power 4. So this becomes 1 plus u square. 1 plus u square. How many of you people can tell me how to integrate this du over 1 plus u square? Okay, let's talk about the limits now. When you have x equal to 0, your u is going to be 0. And when you have x equal to 1, your u is going to be under root 3. So we have the limits from 0 to under root 3. 0 to under root 3. These are the limits. And people, please remember that d by dx of tan inverse of x is 1 over 1 plus x squared. Therefore, the integral of 1 over 1 plus x square would be tan inverse of x. Okay, so if you integrate this, I mean 1 over 1 plus x square, so that should be, you must be able to write that tan inverse of x plus c. So we have here, we are done with this integration. This is going to be 1 over 2 under root 3, and limits from 0 to under root 3, that is tan inverse of u. Okay, and this is 1 over 2 under root 3 tan inverse of under root 3 minus tan inverse of 0. So you people get 1 over 2 under root 3. Tan inverse of under root 3 is pi by 3. And pi by 3, yes. So this is pi over 6 under root 3. That is the area. We can further rationalize this to get to the answer that is there at the back. So that would be under root 3 pi over 18. We're going to basically multiply them, both of them, by under root 3 over under root 3. So you get under root 3 pi over 18. So that is the area of this shaded part. Okay? Do you have any question, बच्चों? So, Bas, let's go to the next question then.